Welcome back. Like I said on the previous recording, we now know how to get an idea of something being acidic or not based on the concentration of hydronium. The higher the concentration of hydronium, the more acidic it is, but the concentration is given on powers of 10, so a lot of zeros in between. So we need to come up with a scale that is easier to use and to communicate. And for that, we are gonna come up with the POH scale and the pH scale. And once we know how to read pH, we're going to be able to go from pH back to the hydronium or from POH back to the hydroxide. So how are we going to do that? Well, let's discuss this first. Like I said before, we have been calculating hydronium and hydroxide. And we have been seeing those values in powers of 10. We know from the KW that the 10 to the minus 7 is what defines the water constant of 10 to the minus 14, 10 to the minus 7 hydronium, 10 to the minus 7 hydroxide. So any number that is smaller than that for the hydronium, that will mean acidic. Any number that is bigger than 10 to the minus 7 for the base, that's what we call basic. So we're going to take that scale, which is on powers of 10, and we're going to change it to a new scale that goes from 1 through 14, or through 14 from 1. So, and we're going to call that scale the pH. Notice that pH and POH have something in common. They begin with P. The P is just a mathematical function. P is the same as the minus log of whatever we're talking about. So if we set pH, we're talking minus log of the H plus or the hydronium. If we set POH, we're talking minus log of the hydroxide, but we're talking concentration, so we put the brackets. If we set pKa, we're talking about the minus log of the Ka, whatever that is. The point is, P is nothing more than the minus log, the log key on your calculator with a minus on front. So that allows us to take these numbers that we were talking about, for example, 10 to the minus 5, and we can say hydronium concentration equals 110 to the minus 5. So the pH is going to be the minus log of 110 to the minus 5 concentration. And when we put that on the calculator, it tells us that the pH equals 5. So we're going to take that power number. We're going to use the P function or the minus log, and we're going to come up with a scale that just goes from 1 through 14. So the bigger the number on the pH scale, the more basic it's going to be. The smaller the number on the POH scale, the more basic it's going to be. So we're always looking for the smallest number. If we're talking about being very strong basically, then we're talking about a POH that is very low number. If we're talking about being very basic, then we're talking about pH, which is very low. So pH is for acidity, pOH is for basic. So a problem like this, we're just going to calculate the pH, and then we're going to decide if it's acidic, basic, or neutral. Because based on this scale, 7 will be neutral. Anything below 7 for the pH is acidic. Anything above 7 for the pH is basic. For the pOH, anything below 7 is basic. And the scale is backwards, so 14 to 7. Anything from 7 to 1 is going to be, anything below 7, 14 through 7 is acidic. Anything above 7 on the pOH scale is basic. So you can see how this can be confusing. Are we talking pH or pOH? So let's do something. Let's concentrate on pH. So we're just going to concentrate on pH, and the lower the number, the more acidic it is. And 7 is neutral. So a problem like this. What would be the pH of something that is 1.7, 10 to the minus 8? So pH is nothing more than the minus log of the hydronium. So that's going to be minus log of 1.7, 10 to the minus 8, brackets because we're talking concentration. And when we put that in our calculators, this is going to tell us that if we look for the minus log of 1.7, 10 to the minus 8, that's going to give us 7.77. So the pH is 7.77 on this case. So any of these problems, since we are given the hydronium, all we're going to do is minus log of that number. So pH for the second one is going to be 7. pH for the last one is going to be 5.66. So all you have to do is minus log of the hydronium to get the pH. So the first one, 7.77. So we're only looking at the pH scale, so we don't get confused. 7.77 is above 7, so that's going to be weakly basic. For the second one, 7, that's going to be neutral. And the last one, below 7, so that's going to be weakly acidic. So that's how we find out the pH. That's how we find out the value of the acidity. What about the pOH? Well, if we're going to do pOH, let's forget about the pH scale and let's use the pOH. So pOH is nothing more than the minus log of the hydronium concentration. So if we do the first one, it's going to be minus log of 1.7, 10 to the minus 8, which is going to be 7.77. The second one is going to be, you notice I was lazy, so I used the same numbers, but we do in pOH now. And this one is going to be 5.66. Using the pOH scale, 7.77 is going to be basic. 7 is going to be neutral. Remember, we're using the pOH scale. And 5.66 5.66 is going to be basic. So let me go back to the first one. The first one is wrong. So it's 7.67, but I was reading the pH. I wasn't reading the pOH scale. So 7.77 would be this way. So that would be acidic. You see what I like to just stick up with one scale? It can get confusing if you start using both scales at the same time. So make sure that you know what scale you're looking at and which way the numbers are moving. So with that said, go ahead and do that daily work where both of them are combined. So make sure that you're paying attention. This will be hydronium, hydronium, and hydronium. And this is hydroxide and hydroxide. So make sure you know which scale you need to use. What about this? Now we need to calculate not the pH, but the concentration given the pH. So we know that pH equals minus log of the hydronium concentration. So if I want this, I need to get rid of that. So the inverse of the minus log is 10. So what I'm gonna do, I'm gonna do 10 to the power of that. So 10 to the minus pH equals hydronium concentration. So that's what we're gonna do that. Hydronium concentration is gonna be 10 to the power of the minus pH. Hydroxide concentration is gonna be 10 to the minus power of the pOH. So those two formulas are the ones that you need to be able to use. And they come because we are eliminating that, which gives us that over here. So let's do these problems. So the hydronium concentration is going to be 10 to the minus 8.55. The hydronium concentration for the second one is going to be 10 to the minus 1123. The hydronium concentration for the third one is going to be 10 to the minus 2.87. And the hydronium concentration on this one is going to be 10 to the minus 1.22. So let me do the first one so you can double check on your calculations later. So let's see. So 8.55 negative, 10 to that is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. That's going to be 2.82 times 10 to the minus 9. So you get that straight from your calculator. So all you have to do is just use your 10 to the x key on your calculator. At least on mine, I put 8.55 negative, and then I click on 10 to the x, and I get my result. However, this problem has another question. The other question is, what is the hydroxide concentration? Well, there's two ways to do that. You know that if you have 1 10 to the minus 14 divided by hydronium, you get your hydroxide. So once you find that number, then do that and you get your hydroxide. The other way is by doing this. pOH plus pH equals 14. So that 14 keeps coming up, right? So if I'm giving the pH, then 14 minus pH equals pOH. So my first one, 14 minus 8.55 is going to give me 6.45. Actually, no, 5.45. So my pOH is 5.45, so my hydroxide is going to be 10 to the 5.45. So that's how I will find my hydroxide concentration. You can either use the KW formula, or you can use this new formula that I just showed you. pH plus pOH equals 14. So now you should be ready to work on that. So make sure you find the hydronium first, and then use whatever of those two approaches you need to use to find the hydroxide. And once we do that, we're done with that part, which tells us that we have only one remaining lecture to complete the last chapter of our course, which is a big accomplishment for you and for me. So when you come back, we will do our last part, end of the chapter, where we will be talking about buffers. So see you soon. Take care.